Okay, Physics 30 is moving on. Page 105, we'll do question 2 as well. A photon has 450 mega electron volts of energy. What is its wavelength and what is its momentum? Okay, so its wavelength. Energy is equal to hc over lambda, and so lambda is hc over E. Now, in the case of using Planck's constant, we want to use the 6.63 E negative 34 version because it involves joule seconds. Okay? So I'll put my units in here so you can see what's happening. Meters per second for speed of light. And then the energy, 450 E6 electron volts times 1.6 E negative 19 joules for every electron volt. Okay, so notice here I have my units set up, and what we can do is we can start canceling. So I'm going to cancel off the joules, the electron volts, the meters per second. The second unit cancels with the second, and we're left with just meters. Okay, let's do the calculation. Okay. Okay, I get the following here. Just a second. Oh, pardon me here, I just didn't put in the E6. That's better. 2.7625 E negative 15. So it was E6 there that was messing me up. Okay, that's fine. So in fact, this would be essentially 2.76 femtometers. Femto is a prefix times 10 to the negative 15. Okay, let's try another question here. Let's try question number 5. A 2.80 picometer X-ray photon deflects off a proton initially at rest. If the proton has a final kinetic energy of 4.33 times 10 to the negative 14 joules, then determine the wavelength in picometers of the deflected X-ray photon. Okay, this is all about conservation of energy, right? So the energy of the photon is going to be equal to the energy kinetic for the electron, okay, plus the energy of the photon after the collision. So let's figure out the energy of the photon after the collision in the problem. So energy of the photon afterwards is going to be energy of the photon initially. Subtract away the kinetic energy of the electron. Well, the energy of the photon initially, since we know it has a 2.80 picometer, right, for a wavelength, we can calculate that. So that'll be hc over wavelength minus ek for the electron. Okay, let's do the calculation in a second. Let's just put in my numbers. 6.63 E negative 34 times 3 E8 over the wavelength 2.80 E negative 12. And then subtract away the 4.33 E negative 14. Okay, the calculation. 3 exponent negative 14. Okay, 2.77357 E negative 14. And now that we know the energy of the scattered photon, we want to know the wavelength of the deflected X-ray photon. So we can use the formula solving for the wavelength. That would be energy of the photon after. Okay. Just a second here, hc over wavelength. Oh, pardon me. This is over hc, and then I need to invert it. I just messed up. I put the wrong thing on the top. It should be hc over E photon afterwards. Okay. And here we go. Put in my numbers. 6.63 E negative 34 times 3 E8 divided by my 2.77357 E negative 14. Okay, 7.17 E negative 12. And that would be meters, and so it'd be 7.17 picometers. Okay, thank you very much.